A very good morning all. I hope everyone doing fine in this pandemic situation. So this webinar is organized by Department of Electrical and Electronics Engineering, a webinar on AI techniques in power systems. So about Guru Nanak Institute of Technical Campus. So GNI is one of the premier institutions in Telangana state. So it is developed into a gateway of privilege and knowledge, research and inspiration. The institution offers graduate and postgraduate courses over 7 disciplines of engineering. So and also MBA and pharmacy also they have around 9,000 students from all over the country and more than 250 international students from various countries are part of this Guru Nanak Institution Technical Campus. So 700 plus strong team of faculty members are imparting academic instruction through research and innovations. So the infrastructure includes separate building for each department and residential accommodation for boys and girls. So 1600 boys and girls, they have different residential blocks are there. And so one of the beauty of GNI, so decode an IT park. Recently they decode an IT park. It is IT park means Digital Engineering Center for Offshore and Domestic Enterprise. So it is the India's first IT park within the institution's campus, providing part-time employment for current students and the past students for full-time employment they are providing. The institution has awarded the best place to innovative in UX India 13 International Conference at IIM Bangalore and excellent innovative institute in AP awarded by CCMA and an award of excellence. So first of all, our sincere gratitude to management of GNI for accepting our invitation and conducting this webinar. So our special thanks to convener sir, Professor P. Pardasarthi sir, Associate Director of GNITC, and our sincere thanks to beloved HOD Dr. K. Shanti Madam and Department of EEE GNITC campus and coordinators for organizing this webinar, Mr. K. Rajshekhar sir, Assistant Professor, Department of EEE, and Mr. J. Mahesh Yadav, Associate Professor, Department of EEE GNITC campus, Hyderabad. So thank you all for joining this session. So before joining this session, so myself Srinivaslu Ala, I completed my MTech in power systems. So from the past few years I am working as a power electronics engineer in Pantex Solutions. So before starting about the session, so our profile of Pantex Solutions. So Pantex Solutions origin in 2004. We have 7 branches. More than 100 employees are working in different Pantex Solutions branches. So already we conducted 200 workshops. So in various colleges from all over South India, and we reached almost 850,000 students nearly. From the last 15 years, we are providing different various workshops and industry projects. And our portfolio, if you see our portfolio, research and development for industry projects, faculty development programs, and hands-on training and workshops for engineering students, and short-term courses and value-added courses on different domains, and academic project training Pantech provide, and customized design service and state-of-the-art and research and development. So which area we people are offering courses? So for electronics and electrical domains, we are offering the courses and workshops and faculty development programs we are conducting on these domains. So Internet of Things, Artificial Intelligence, Embedded Systems, Robotics, VLSI, FPGA and TMS process, and image processing, OpenCV, network simulation, and for electrical students mainly power electronics, power systems and e-vehicle. So, and computer science and IT domain people, we are offering big data, data analytics, internet of things, Python, Android, and Android application development, data and image processing and text mining, cloud computing, mobile computing. So in all these domains, from the past few years, we are offering courses and we are providing workshops and faculty development training also. So today, what is the content today we people will discuss? So in this webinar, mainly conducting this webinar, artificial intelligence, what is the role will play in power system, right? So what is artificial intelligence? So why we need artificial intelligence? What is the motto or goals of artificial intelligence? And here we will discuss the necessity of artificial intelligence in power systems area, and what are the techniques, AI techniques in AI techniques in power system area we are implementing. So in AI techniques, mainly we will discuss ANN, artificial neural network, fuzzy logic controller, and expert system techniques, genetic algorithm. These are the main 4 techniques comes under AI techniques in power systems. So these 4 we will discuss briefly. So before starting about that one, we need to know about what is artificial intelligence, right? So what is meant by artificial intelligence? So in today's world, if you see today the situation which we are facing, in today's world the technology is growing very fast and we are getting in touch with the different new technologies day by day, right? So people, we are sitting in different corner of India, but we are gathering through Zoom, right? So through YouTube we are discussing about this webinar. So the technology day by day, it is going very fast. So the future is no longer a time frame, the future is mindset. So what is artificial intelligence? The future will be decided by with the mindset only. So AI is one of the fascinating universal fields of electrical and computer science, which has a great scope in the future also. Coming years, we will see the AI is a big market. So virtual reality, augmented reality we are talking, right? So we don't want to depend upon the manpower. So which we made the machines, AI machines will play a key role in the industries, automotive machines, right? We are talking every industry, they are looking about the AI machines. So they are making the machines also with AI, means there is no driverless car also they are trying to implement. So AI holds a tendency to cause the machine which we are made, it will be do all those works. So the man no need to work, man have less work, the machines will work more, they have the ability to think their own self. So like that we will create the machines. How it will be work, how the artificial intelligence play a key role in power system area, because power system is a big network, right? So if you see here, the artificial intelligence or AI, the ability of a computer to act like a human, think humanity, think rationality, act like a rationality, act like a humanity. We need to think humanity. So the machines which we people made, whether it is a robotic machine or any artificial thing, the machine will think like as a human. So it will be solves major problems in the industry, whether it is a power system industry or any automobile industry also. The artificial intelligence machines will clear so many problems. We don't need to touch the system, power system engineering also. So here the what are the machines we people will developing, through algorithms only we are developing. So the main techniques we are following, right? So by implementing those techniques in that machine, the machine will clear major complex problems in the power system network. So here you can see here, humanity will change more in the next 20 years than in the previous 300. From the last 3 centuries, what we are seeing in the globalization or industrialization we are talking, right? So next coming 2 decades we will see a bigger change. So a tremendous change will happen coming few decades. So science fiction is become a science fact. Imagination and foresight are new mission critical. So what we are imagining in our mind, that will be applicable in real time world. Real time world, those problems, what are the imaginary problems we have in our mind, the science fiction we are talking about, the science fiction is becoming a science fact. Coming years we will see. So what is clearly, if you analyze the artificial intelligence, means artificial intelligence is majorly talking about two words only, right? Artificial and intelligence, where artificial will defines man-made, where artificial defines man-made and intelligence defines thinking power. Hence, a artificial intelligence means a man-made thinking power. No one is not. So we people are designing the machine like to think ourselves. So robotic machines, right? So here, for the first time in human history, by observing this figure, you can analyze from where we are started, our journey. From the first time in human history, technology is going inside of us. By visualizing this picture, you can get clearly one idea how the artificial intelligence is in our mind. So within ourselves, within the technology is in our body. So within the human body, the technology or artificial intelligence we are inserting, right? So man-made chips. So if you are observing any Hollywood pictures also, they are placing the chips in their human body. So they're detecting all the problems. So they're decoding what are the problems they will face, how to act like a human, how to act like a human, how to take the decision when a system network, it will be clear we discussed. So through these algorithms we can clear all those problems. You can see here. So coming years, data, if you have the data, you are the richer than anyone. If your data is the new oil, if you have sufficient data with you, you are the master of in your own world. You can, no one can't buy you. You can rule the world if you have the data means. So the artificial intelligence is the new electricity. So if you have the idea to develop any artificial intelligence algorithm, so you will become more rich, right? So then the companies also looking from those people who have innovative thoughts on artificial intelligence. Artificial intelligence is the new electricity. So if you have the data, it will be, you don't need to depend upon, you don't need to think about the money also. So the data which it will collect all the money, it will solve all your problems also. So why we people need artificial intelligence? So we need to raise some question, right? So normally we are very fine. So why we people need artificial intelligence means with the help of AI, you can create such software or device which can solve the real world problems very easily and with an accuracy, such as health issues or marketing issues or traffic issues, etc. So if you take a best example on COVID, which we are facing now, COVID-19, right? So the coronavirus. So coming month, how many cases will increase in Hyderabad city? We can estimate through these artificial intelligence ANN algorithms. If you calculate, you can easily predict the machine. You can predict how much cases we will face, how to take care ourselves in our locality, how many cases will increase coming month or coming September, then how to solve those, how to face that situation, you can easily get. So the health issues or marketing issues or financial or traffic issues or weather monitoring also we can do with the artificial intelligence. We can't say we will get the exact solution, but we can reach the approximate solution. We can give the exact solution. If you are observing the weather monitoring, if the cyclone will come, how they are predicting very easily. They are telling, right, within the time tomorrow at evening 4 p.m. to 6 p.m. the cyclone will cross to near to Kakinada or Vizag city, like that. They are telling, right? So with the help of AI, you can create your personal virtual assistant also. That means you can easily predict the problems, you can give the solution, and you can create your own virtual assistant such as Cortana or Google Assistant. Now how it will help if you see the Google Assistants or Siri in Apple. So these, like that, you can create your own virtual assistant, and it will be it will update all the information to you. With the help of AI, you can build such as robotics, which can work in an environment where survival of human can be at risk. Now we are facing, so the people who are wearing PPE kits and they are treating the people, right? With the man-made robots, they can work very easily. We can't survive without wearing any PPE kit. We can't survive in the hospital. So if you made a robot, the robotic machine will treat the people like human. So we can't, so the people who are not where we can't survive, at that place we can send easily the robotic machines which are made up of with artificial intelligence. So AI opens a path for other new technologies and new devices and new opportunities also it is providing. So here, what is the goal of artificial intelligence and what is the motto of artificial intelligence? You can see here, replicate human intelligence. The human intelligence, human mind, it will be replicated and solve knowledge intensive task, an intelligent connection of perception of action, building a machine which can perform the task that requires human intelligence, and creating some system which can exhibit intelligent behavior, learn new things by itself. So now we people are learning, right? So artificial intelligence or machine learning or deep learning, in the artificial neural network also, which algorithms we need to prefer, whether people will prefer feed-forward networks or recurrent networks or dynamic neural networks, which one we need to prefer. So like we are learning by itself, right? So like that, when you made a machine, the robotic machine, automatically it will learn, it have the ability to think its own, and so the learn new things by itself, demonstrate and explain and can advise to its user also, and it give the advices to the people who are not able to solve those problems. So if you see here, so we are talking about the AI, artificial intelligence, and why we need artificial intelligence, what is the goal of artificial intelligence we are discussing. But what is the role it will play in power system? So power system, if you see here, Indian power system, it is a big network. So grid connected PVC, grid connected network. So the power system engineering is an important branch for electrical people. Electrical engineering that deals with which one. Power system means we can't say it is only transmission, we can't say it is only distribution. The combination of generation, transmission, distribution, so and utilization of the electrical power, we completely the generation, transmission, distribution and utilization of the electrical power, we can say the power system network. So it is a big network, so the complexity become more in this power system network, right? So over the past 25 years, so feasibility of the application of AI on various topics in power system has been explored by a number of investigators. The researchers have many challenges on this power system network. They are facing many challenges how to solve those problems, complex problems, real world problems or imaginary problems they are getting. Then how much effectively they want to solve. So by using these AI techniques, they are every day they are trying to get a new algorithm or a new technical topology or new controlling topology also they are trying to implement. So those are the topics explored, vary from load forecast to real-time control and protection and even maintenance. So we need to maintain, right? If you observe any subsystem in our surrounding area, so every day the three people they will work on by shift based, right? Shift based. So three people man-made, we need 3 manpower. So compulsory they are operating for that surrounding people purpose. So they are monitoring that subsystem. 3 people they are continuously monitoring 24/7. If you are designed a robotic machine, you can place that robotic machine in that subsystem. It will monitor that systems, right? It will monitor very easily. So we can reduce the manpower by implementing these algorithms. And you can see here, so the necessity of AI in power system, if you look at here, for industrial developments with the power system expansion, stability, strengthening and reliability, technical advancements, selection and dynamics response of the power system are essential. So we are facing so many problems, unwanted problems are created. So when suddenly the weather changing, so at that time automatically the faults may created on the power system network, whether it is symmetrical faults or unsymmetrical fault, suddenly the power system, so we can't predict, right? The fault may occur on the transmission network, at what point also we can't predict, but then we can easily analyze where the fault is located, where the fault is occurred through this artificial, with by placing some sensors we can easily predict from by the long. If you see most of the our Indian power system network, we are transmitting the power through overhead transmission lines only. When we are because of economically it will be compared to the underground cables, economically it will be less cost, so we most of the people they are preferring overhead transmission lines only. If we are placing any in the transmission network any sensors, so from the long distance, so from that substation to we are the consumer, so we people are far away, from at least 20 kilometers we are far away. So then middle of the time if any fault occurred in the middle of the transmission network, we place any sensor, I mean that sensor will detect and it will send a message to you. Whether if you are connecting now, globalization changing, right? So everyone thinking about the smart grid they are thinking, smart city, smart village, like that they are thinking, right? So in that area also we can implement these artificial neural network or artificial intelligence algorithms, or with the IoT sensor also we can implement. So for industrial development, with the growth of power system, complexity in the networks is increased tremendously. So the complexity become more difficult to analyze those problems. So as a consequence of this power system analysis, by conventional techniques and conclusions from the acquired data, the process for the information and management of remote devices. Suppose we people are grid connected, we are all connected to grid connected. We are not taking directly from the generation. So we are generating the power, different power plants, whether it is thermal power plant or hydro power plant or renewable energy sources power plant. We are generating the power, we are connecting to the grid. From that grid we are distributing the power. Why we people are connecting to the grid means to get the continuous power supply without disturbing. So because we people are sitting in rural area, we people have less power is enough to run our home application devices, but the industry which are located in Hyderabad city, they need a huge amount of power. So the grid people will monitor all these things, the grid people will distribute the power, how much power we need from the industrial area, how much power we need agriculture purpose, how much power we need to give domestic applications or home applications or residential complex. So depending upon the consumption of power they will distribute. So by connecting all the generation power plant at one point, we can easily monitor, we can easily distribute. So if you people are taking the power from the solar PV plant, suppose if you are taking without connecting any grid, directly you are taking the power from the solar PV plant. Then if the solar PV plants, when they will generate the power, normally daytime only they will generate. When you are taking the power daytime, during the night time you can't get the power, right? So when you people are connected to the grid means grid people have they have huge amount of power, they can easily distribute. So all these problems, what are the problems we are facing, whether it is generation, transmission and distribution or utilization of the power at the consumer side, so they have different complex problems. So all these problems we can analyze with an easy manner by using the artificial intelligence technique. And here, what are the AI techniques? So modern AI techniques that include, these are the following techniques you can see here: artificial neural networks, so and expert system techniques, and fuzzy logic systems, genetic algorithm. These are the four main techniques comes under the artificial intelligence techniques in power system area. So what is meant by artificial neural network? Artificial neural network or fuzzy logic neural network or expert system networks or genetic algorithms. So which role will play, we will discuss briefly here. What is the artificial neural network? So artificial neural networks are biologically inspired by system. It will be inspired, the whatever the artificial neural network we are seeing. So it will be inspired by the biological nerve system in our human body. They are inspiring by our human body. If you see in our human body, if you are touch on top of your any part of your body, you have some sense, right? We people have some sense. We can easily get that sense. So then we can easily learn. If you get some pain on your body, then you have immediately the nerve system will give some sense to your mind. You will at each knee part you are getting the injury. So then you can automatically you will give the some solution to that part. So like that, these artificial neural network are inspired by the human itself, human biological nerve system. These are inspired. So the ANN, artificial neural network mathematical model, simulates the human biological neural network for processing information, where each neuron produces one output as a function of inputs. Each neuron will produce one output as a function of input. So each type of neural network is capable of some specific work after being trained, and is able to conclude function from observation faced in real life, such as function approximation, classification, and data processing, etc. So we can calculate the data. So these, like human body nerve system, through by inspiring these nerve system, they are designed the artificial neural network. So these, you can see here the input neurons. So you can see symbolically represented here, neurons, synapse, and layer. So the inputs you people are giving. So if you are giving the input data with you don't have any clarity on the input data also, but the artificial intelligence, what you made the algorithm, it will give the solution also. If the that is whatever the input you are giving, it is not correct, suppose there is some mistakes are there, so even though that will give the solution, exact solution, or what you need to conclude, what you need to decide output, it will give automatically. So these inputs and output, in between the input and output, how our human body nerve system will be connected, like that we will train the system in this neurons path. This one we can call it as a hidden layer. Hidden layer, it will be connected. So by connecting the hidden layers, number of cycles it is going, right? So number of synapses we are connected, multiple synapses are connected. So then the system becomes more stable. So the artificial intelligence, the machines which will be more robust and rugged system also, it will be easily detect the problems. It will be easily detect the problems. So we are designed like that system. So hidden layers, we created infinity rules, infinity layers we can create. So then the problem where we are getting, we can easily identify. You can see here a neural network consists of some layers of artificial neurons linked by the weight connections, input layer, hidden layer, and the output layer. So the input layer inputs do not process the data and information, but distribute the other units. So whatever the data in the input layer, it will distribute the information to other units. So here the hidden units provide the ability to map or classify the non-linear problems. So in this hidden layers only, where if the problem it is a non-linear load problem, the complexity become more in that system. So this hidden layer have the ability to collect all that data and to solve those problems, whether are to classify the non-linear problems or linear problems. This hidden layer will collect everything which we are taking from the input data. So it will be taken. So then it will be analyze whether it is a linear problem or non-linear problem, how to solve those problems. And output layer here, it encodes possible values to be allocated to the case under consideration. So what is artificial neural network characteristics? So artificial neural networks are fast and robust, and they do not need any appropriate knowledge of the system model. Since they are fault tolerant, they can handle situations of incomplete or corrupt data and information. even though the data is incomplete or corrupt data and information, so these artificial neural networks will clear that data. So whatever the data you people are giving from the input to train that system, you need to train the system. So then even though that data is incomplete or corrupt data, but it will take through that hidden layer, it will analyze all those things and it will give the solution, exact solution what you people need. So they have the learning and data adoption ability. The artificial neural networks have the ability to learn themselves easily and adoption of ability. So on the other hand, you can see artificial neural networks cannot perform a task other than one for which they are trained. So whatever the data you people are giving from the input side, that data only will be trained. So it will not take from other data. It will not be taken other data. For any other task, they have to be retrained. You will get the point, right? So what we are giving the information, that information only will take that that data only will be trained in the artificial neural network. It will not take any other data. Suppose you people need to find any power system. So the voltage stability you need to find in the power system net. So regarding that data only it will take. It will not take any other data. It will not take any other data. If you need to train the other data means, so you can again train the system. So ANN artificial neural networks always generate the result through the input data is unreasonable. If the data is unreasonable also, it will be trained and it will give the solution to here. So where we can use these artificial neural networks, load forecasting system also we can use these artificial neural networks. Fault diagnosis. So when if you are facing LG fault or double LG fault or triple LG, unsymmetrical faults, when during the transmission network the trees are fall down, then suddenly fault occurs. So whether it is LG fault or double LG fault or triple LG fault. So then to detect those problems, these artificial neural network will help in that area also. So security assessment, state estimation and contingent screening, voltage stability assessment also it will give the good solution, and protection. So the protection or power system protection and load modeling also. In all these areas we can utilize these artificial neural networks. Regarding that we need to train the system. We need to give the information, we need to train the network. So then only it will give the exact solution or it will solve the complex problems mainly. And here, what is the methodology you need to follow here? The main methodology in this artificial neural network, real world problems in generation, whether it is in generation or transmission or distribution of electricity, can be fed to the artificial neural network to obtain a solution. If you people are facing in the transmission network any problem, whether it is a fault or stability problem, then you can train the system. You need to collect the data, you need to train, and you need to get the solution. So 70% of the data you need to train, 30% it will take the 30%. So 70% of the data which we are taking, it will be you need to make. So that data you people need to train. So 30% it will take and it will give the solution exactly or approximate solution it will give. Fuzzy logic system was invented by Latif Jade, a professor of an American university. So the fuzzy logic systems like it will be true and false. Whether we people are, suppose we people take breakfast or not. So there is only two answers, either yes or no type only. But in that fuzzy logic system, conventional fuzzy, either in that true answer, either true or false, either then we can take in power system manner either 0 or 1. True means 1 we can take, false means we can take 0. In between the 0 to 1 we can create infinity rules by taking these fuzzy logic system or fuzzy sets or fuzzy algorithms. So these are all implemented by Latif Jade, and he is this fuzzy logic will comes under artificial intelligence also, and the fuzzy signals are compared with the fuzzy settings. So here mainly you need to analyze fuzzification process data, fuzzification and defuzzification, in between the fuzzification and defuzzification. So it will be similar to the artificial neural network only, but Compared to the fuzzy logic system, artificial neural network, it will be recently implemented. From the last 3 decades, they are implemented. So it will give more good solution. So, and in artificial neural network, and after that, fuzzy logic system you can prefer regarding to your research analysis. Fuzzy logic signals are compared with the fuzzy settings. Several relaying criteria are used in parallel. The criteria are aggregated by means of formal multi-criteria decision-making algorithm. So these are all comes under decision-making problems. So you need to give the fuzzification, input processing data. So the tripping decision depends upon multi-criteria evaluation of the status of a protected element. You need to protect which type, whether you need to work on protection, or you need to security assessment, or you need to analyze the stability or load forecasting. You need to decide regarding that. You need to design the these fuzzy logic rules. You need to train the fuzzy logic rules. Suppose you need to, when you people have designed a fact divisor system, suppose whether in the fact divisors, how many, what are the fact divisors? StatCom, DStatCom, and DVR, UPTSC, shunt active filter. These are all comes under fact divisors only, right? So when you are designing the fact divisor, so why we are designing the, why we need fact divisors means those are all power electronic based devices only. So power quality improvement or power quality problems which we are facing, the sag, swell, or voltage striking, or voltage flickering. So to analyze those problems, we need fact divisors. So in that fact divisors, you need to maintain the DC link voltage constant, right? So when we are designing a shunt active filter or DStatCom means compulsory you need to maintain the VDC, DC link voltage constant. So before that, then only the inverter will convert that DC constant DC into AC, then it will be solved. Whether it is a sag problem or swell problem, it will be cleared. So in that case, to maintain the DC link voltage or to reduce the ripple level voltages, or to reduce the ripple level voltages of voltages. So this fuzzy logic system you can implement there. You can see here how to create the fuzzy logic. Fuzzy logic system was developed in initially 1965. Already I said a lot of Jade become popular in technical problem solving. They are considered as a mathematical. So it is not a programming language. If you see in this fuzzy logic is not a programming language. It is a logification. So you can see here the graph here. So what are the steps you need to follow? So first you need to analyze the problem. If you get the problem, so you need to reduce, or you need to you are identifying the problem. Then you need to collect the data. According to that data, you need to fuzzification you need to give. So fuzzification means you need to create the rules. Fuzzification rule, input variables. So you need to take the membership function, selection of membership function you need to done. So then according to that membership function, fuzzification, whether you will create 25 rules, or you people create 129 rules, or you people create 3 rules, according to your requirement, you need to design the fuzzification rule. Whether you people are preferring 2 input variables or single input variable. So then you need to analyze the defuzzification. So then in between the fuzzification and defuzzification, you need to analysis you need to done. That means you need to create the rules according to this much rule. You need to, according to your rules, your output will come. So defuzzification will come. So then only the decision it will take whatever the rules you people created. According to your rules only the decision. So the output will come. So the fuzzy system will take the decision and it will give the solution. So it is also purely artificial related only. It is depending upon human thought. What is your problem? You need to identify. According to that problem, you need to analyze the solution here. So the fuzzy logic characteristics, if you see here, fuzzification provides over simplification, superior expressive power, and an improved capability to model a complex problem at low cost. So economically, we need to reduce the burden. So if you economically, if you are facing if you are investing more cost high means, then the people are not much interested on that system. If you developed any DVR or any DStatCom, if you are developing like a product, a real-time product, in that product you are implementing the fuzzy logic algorithm. So then economically you are telling the high cost means the people who are all the people are not bear that much cost, right? So then reliable cost you need to analyze. You need to design the product cost you need to put in the market very affordable cost. So then only the people will utilize your product. So it allows a particular level of uncertainty throughout an analysis. As a consequence of allowed uncertainty, it minimizes the problems and complexity and available specific information. As most of our power system analysis is performed either with an approximation or with the assumption based data. So if you see our power system analysis, we are collecting the data, right? Every day, the people who are working in generation side or distribution side. So we have in Telangana, if you are observing, Genco, Transco, and TSPDCL also available, right? So there, why we have three separate departments? The people they need to analyze the problems where. So depending upon Genco, the people they will work on different things. Transco people, they are working on substation and transmission line, and distribution side these people TSPDCL they will work. So all the people, if you are analyzing the power system, they are performed with an approximation or with assumption based data. Fuzzy logic can be great use of derive a stable and exact output free from the uncertainty. So if the problem become more complex, it have the ability to give the solution. This fuzzy logic have the ability to give the solution. So how fuzzy logic can be used in power system? Fuzzy logic can be used for designing the physical components of power system. They can be used in anything from the small circuits to large mainframes also. We can, from the small minute components to large components or large products, we can utilize these fuzzy logic system, and they can be used to increase the efficiency of the components used in the power. What are the components we people are using in the power system network? So it will whatever the, if you observe whatever the product you people are purchasing, what you will see, the product how much long life it will come. So that means according to the long life only you will calculate this product have the good efficiency it will give. So if you are purchasing a good product and it will give only 6 months long life, after the 6 months the product may damage, then how you people will think? You people will feel bad, right? So whatever the product you are purchasing, whether it is power system elements or power system components, so the product component it will give components will give the efficiency more, and it will give the long life, means then you will feel better. So as most of the data used in power system analysis are approximated values and assumption, fuzzy logic can be these. According to that, we need to develop a linear model of our plant sensors and actuators. So we need to collect the data, we need to identify the problem. According to that, we need to follow these steps. So then determine a simplified controller from the control theory, develop an algorithm for that controller. So the fuzzy logic algorithm you need to develop for that controlling system. So then simulate, debug, and implement the design. So these are the 5 steps you need to follow. Understand the physical system and control requirements. Design the control for using the fuzzy rules. Simulate and debug the and imagine and try to implement that design also. From the fuzzy logic provides the conversions from the numerical to symbolic inputs and back also. You can see here where we can use these applications of fuzzy logic controller. You can see here stability assessment and enhancement, power system controller, fault diagnosis, security assessment, load forecasting, reactive power planning and control. So reactive power, so when we are connected to nonlinear, the reactive power become more. So that if you are getting the reactive power at load side more, means then automatically the power consumption become more, and it will make again burden on the consumer itself. So you need to identify that problem, reactive power you are getting more. So you need to reduce the reactive power, you need to send the active power more to the load side. So we can't all the people will know the reactive power is a useless power. So but the reactive power will help to drive the active power. So then how effectively we can send the active power to the load side means, so these fuzzy logic controller system, either power quality problems or fault tolerance problems or security assessment or load forecasting, in all these analysis or plant modeling, whether it is a single area or two area or three area plant modeling system also. Whether so normally in AC power we need to analyze means then whether we can control three things, either frequency or number of phases or magnitude, how much voltage we need to do. So these three things we need to analyze, and the state estimation. So in all these cases we can use the fuzzy logic controller. So if it comes, and another one thing is expert systems. So most of the people, they are following those two techniques only. One is artificial neural network and fuzzy logic techniques, and another one AI techniques, expert systems will come. So expert systems were developed during the 1960 and 1970s, commercially applied throughout the 90s. So they are developed in 1960, around 60 and 70s, in that area, in that decade. So then the commercially, when it comes real time, they are implemented in 1980s only. It is also called knowledge based systems or rule based system. It is a computer program that incorporates knowledge derived from the experts in a specific subject to provide problem analysis to users. Same thing only. It will be whatever the problems. So we need to analyze the rules and decision trees and models and frames. We need to follow these things, and it uses the knowledge and interface mechanism to solve the problems which cannot be or difficult to be solved human skills. We people face to solve those problems means by implementing these expert system techniques or expert system rules or algorithms, we can the critical problems we can easily solve. The common form of an expert system is a computer program containing of the rules for analyze and recommendations for user according to how we people are creating the rules from that problem. So according to that, it will give the solution to here. So where we can use these applications means expert systems are especially useful for problems when a large amount of data and information have to be processed in a short time. Within the large bulk data we have, within the less time we need to analyze, we need to give that solution. That bulk data we need to analyze and we need to give the solutions means at that point these expert systems will give the good idea. And many applications in power system related to power system designing and analysis match the abilities of expert system. So here you can see this graph also, knowledge acquisition facility and data generation facility, knowledge base and knowledge engineer. So according to the data, so what are the problem, critical problem we are facing, according to that we need to collect the data. Through that data we need to create the rules. So then it will give the what is the exact solution it will give. And here and another animation technique based on the study of natural selection and natural genetics. Here also several methods for increasing efficiency. So if you observe the artificial, whether it is a ANN or fuzzy or expert system or GA, these are all why we need means to increase the efficiency of the power system. If you observe, for every year the 20% losses are occurring in Indian power system. We are transmitting the power through the transmission lines. We are transmitting through that only. We are getting how much losses? 20% of the power losses we are getting. So we need to reduce those losses. We need to increase the efficiency. We need to send the good power to through the transmission line. Through the transmission line means these genetic algorithms or artificial network algorithms will be helpful. So it is the best method for solving complex and nonlinear problems, and it is used for planning power generation, transmission and distribution also. It adjusts the parameter for excitation to solve the voltage control problem and reactive power compensation also. Reactive power compensation. So how the AI is exposure in power system? We are seeing 4 techniques majorly. So how these techniques will exposure in power system means economic and load dispatch, generation and operational planning based, and load forecasting optimization of hydrothermal generation scheduling, and control of voltage and frequency and system stability, sizing of controls by using the fact devices. So through the fact devices only we can solve all those problems, right? So analysis of electricity markets and strategies for bidding, automation for power restoration and management also. So in all these areas, AI will place exposure in the power system network. So AI techniques, so if you see here, to diagnose the faults, fuzzy system means AI techniques for transmission line performance improvement, to diagnose the fault, and artificial neural network to train or to change the values of line parameters based on the environmental conditions, expert systems to deploy the output as a value of line parameters, environmental sensors to sense the environmental and atmospheric conditions and provide input to the expert system. So we people see here a basic example in Matlab Simulink model. So here everyone will know about the Matlab Simulink, right? So all these things we can implement in the Matlab Simulink. Type means all the variables will appear in the workspace. So this is the current folder and this one is the current directory path. So normally if you see here command window, how many characters? Nearly approximately, what is the variable name we can give normally? A is equal, we can give the name, variable name, we can give a simple matrix, right? 1, 2, 3, we can give a vector. So 1/3 vector we are giving. So if you see here, a simple vector you are giving. So whatever the variable name you are giving, the variable name it will be stored in the workspace here. So A is equal 1, 2, 3 you are giving. So this A will be appeared in here. This variable you can see here in this workspace it will. So Matlab or matrix laboratory was implemented or developed in around 1970s for engineering problems. So to solve the engineering problems or scientific problems, Matlab was developed. So before that Matlab, we have Fortran language or C or C++ language, but the engineering students or the engineering or research scientists, the people who are working on the real world, real problems, so they are facing to analyze the programming skills. So all are not able to adapt that programming skills. So then the Cleve Moller, a professor from the Mexican University, he developed the MathWorks or matrix laboratory. So then it will give it will be work purely on mathematical problems only. If you have a mathematical equation, you can solve, you can design that mathematical equation. If you need to analyze the elementary, what are the problems we are observing? So elementary operation of matrix, we can easily analyze. So here by using, we can do two things. Script2 is there and Simulink is also there. So script2, we can say what are the files we are typing there. We can give the parameter value, all the parameter values we can give in the space. You can type here. Simulink also it will come here. I will show you a fuzzy logic PI controller, fuzzy logic controller, which we are designing here. You can see here. This is the shunt active power filter. So through filter. So here in this simulation, this is the simulation library. If you observe the library browser, electrical people, we have, if you people have idea about the Simulink and Simscape, you can easily analyze. So if you see here, this is comes under, so now I am using 2016A version. You can see here, this is Simulink. This Simulink toolbox, if you have the Matlab only purely equations, through that equations you can design, you can take these toolbox, and through this toolbox we have inbuilt functions. So inbuilt number of inbuilt blocks are there. Through these blocks you can design your model, whatever the problem you are facing. So you need to design a differential equation or linear problem or whatever the problem may be. So by taking these blocks you can analyze your problem, whatever the equation you have. So here you can see here fuzzy logic system toolbox is there. So we are working with the Simulink, fuzzy logic and Simscape here. But in this fuzzy logic toolbox, we have only fuzzy logic controller with the rule wear and membership functions are there. But where we are creating the rules, I will show the rules how to create. And here artificial neural network, if you need to design a neural network problem, so here we have separately neural network toolbox also is there. through this neural network or toolbox, you need to train the system in the command window or in .m file. Then you will get the training system to directly simulink model also. So then here how to create the fuzzy logic rules, you can see here, this is the shunt active filter. So without connecting, so each and everyone will know. So here we are using the GUI na. So why we people need to use means here we are interfacing with the Simulink and SimScape. So that's the reason. So in all our mobiles and PCs, if you are observing, we have one GUI, right? We have one screen lock, right? Everyone are using fingerprint or screen lock, right? So in software manner, we can say that is GUI. That means graphical user interface. So here we are using the inductor and capacitor, inductor and resistor elements. So we are transmitting the power through this one. From this grid, we are transmitting through this power through non-linear load. So whatever the non-linear, whether it is a rectifier devices or PCs or in all the domestic application loads will comes under most of the loads will comes under mobiles, TVs, television or PCs will comes under non-linear loads only, or variable frequency drives also we can say non-linear loads. So this active power, how it will be improve the quality of the power. So you can see here, by maintaining the DC link voltage, you can see here, this is the inverter. So this shunt active filter. So here this is the inverter. You can see here. So this is three-phase inverter, right? Three-phase voltage source converter devices. So we have normally 120-degree conduction mode, 180-degree conduction. So this is 120-degree conduction mode voltage source converter devices only. This converter will help to improve the quality of the power supply when we are transmitting the power from the grid to distribution side. So for this one we need to give the gate signals, right? We need to give the gate switching signal. So 6 switching signals we need to give. You can see here. Wait a minute. This active power filter. So for this one we need to analyze the controlling technique. We need to analyze the control technique. Here what is this fuzzy logic PI controller will help means, you can see here, this is the fuzzy logic controller. Here I created the subsystem. So this fuzzy logic controller, here I took the name I given here with ALA23 I created one fuzzy logic system. So this fuzzy file data which I created in the command window, we need to create the command window and KP KI value I took. So error, change in error. Suppose the best how to analyze the fuzzy logic controller for easily understood. Suppose all you people went a restaurant, a good restaurant, you people went a restaurant, then how you people will pay the tip? You need to give the 10% or 20% or 30% tip, you will pay the tip, right? So this fuzzy logic system also, as per the USA people, they are most of the people they don't eat at home. They easily they went to a restaurant, they eat there, right? So according to their analysis, they implemented this one. So you people went a restaurant means, so according to the quality of the food and service, you will pay the tip. Suppose the quality of the food is very good, but the service is very poor. How you are ready to pay 30% tip? No, right? Compulsory you will give the tip 10% only you will give. So according to that, here fuzzy with PI controller, error, change in error, we created the rules. So then you can see here with the PI controller, proportional integral controller, we need to how much VDC reference controller I am giving 380 voltage. So 380 voltage VDC controller output voltage I need to control. So where is the VDC? Here. This VDC we need to give, right? That DC we need to convert into the AC here. This VDC. So this DC link capacitor, right? So this is the capacitor. In this DC link capacitor voltage, we need to maintain the 380 voltage. So how we will reduce? So this is the controlling technique, instantaneous active power theory. Through this one ABC, VABC means this is the source voltage and this is the load current. Here we are analyzing the current harmony or quality of the power supply, we can say, to reduce the harmonics So normally in domestic applications, in all our loads, if we have 48.43% of harmonics also, we are using that loads, but the long life of the product, it will be very less. So normally, as per IEEE standards, we need to maintain the harmonic distortion in any product 5% only. But we are using up to 48% also we are using at our home. But as per the their standard, IEEE standards, we need to maintain the product, whatever the product we are developing. So that product harmonic distortions, we need to maintain 5% only. So this VABC, IABC we are giving to this one. Then in this instantaneous power, what we are doing? Clark transformation. That means 3 by 3 matrix, A, B, C, right? We are giving a VA, VB, VC. That means each phase they are maintaining with 120 degree, 120 degree, 120, 0, 120, 240. Through that we can write the equations. What are the equations? How we will take VA? So sin 0, sin 120, sin 240, cos 0, cos 120, cos 240. Then I naught is system. So here we are transforming the matrix 3 by 3 transformation into DQ transformation, and again you can see here 1 0 0 1 square root 1 by square root 3 and 2 by square root 3 we are giving. So these matrix we are transforming. So then again the compensation, which one we need to compensation? Load current. You can see here this load current we need to compensate. So by using this filter, the power loss we can calculate here, and here the compensating current, we need to compensate the current U of 1, U of T3, and here through this matrix we are doing again inverse Clark transformation. Inverse Clark transform. So initially we are designing, we are transforming ABC to alpha beta or DQ transformation by taking the synchronous reference frame. That means stationary reference frame. So then again inverse transformation we are doing. So then again that DQO we need to convert into the ABC transformation. So here how many switching signals we have? After compensating this one, you can see here we are giving IC compensated current. So but this is the inverter, right? We have in this inverter we have 6 switches. So for that 6 switches we need to give the pulsating signal. So the compensating current, through the compensating currents we are giving IC, IABC we are giving. So through these are the relay blocks. Through this relay blocks we have 3 legs, then we are taking as a NOT gate. So if you observing 1 3 5 2 6 4, we have 6 switches. If you are turning on one switches means automatically at that time 4th switches will be operated. We can operate in each leg at a time only one switches only. If you are operating both switches means it will go to short circuit, right? So NOT gate we are connected. So then here 0 0 0 we connected. So then when the switch will on means then we can take it is as a 0, and off means switch will on means 1, off means 0 it will take. So and here we created a subsystem gate signals we given. So then coupling inductor, then again this circuit breaker we given. In this circuit breaker, so 0 to 0 comma 2 by 5 we given, right? Closed the circuit breaker. So if you open the circuit breaker, then there may be some disturbance occur. So here we connected this one, right? So non-linear load we are implementing the active power filter to improve the quality of the power. So here this B, right, bus creator we done, right? You can see here VABC, use a label I did, and use a label IABC we did. So from this, so here how to create the rules, fuzzy logic rules you can see here. If you directly run the rules means here you need to take the fuzzy. You need to take, so if you need to remove this one CLC clear means if you give the command clear means it will be cleared in this command window, all the variables will be cleared. CLC you are giving. Now you can type how you people will create the rules fuzzy. So this fuzzy logic will help to control the DC link voltage up to 380 voltage. So you need to give the command here on this command window fuzzy. So then one pop-up you will get, fuzzy logic editor you will get. You can see here. fuzzy logic editor, we will get a file. So this is the fuzzification. So when you are taking the fuzzy logic, first you need to analyze the input one. So what is the input? So here if you need to take the two input variables, so go to edit, add a variable. So how many variables you need? Variables you need. If you take kp ki, so you can see here input 1 and input 2 we take. So if you need to output variable 2 means this is the fuzzification. So here you need to give the name input 1 and input 2 or kp ki value you need to give. Then means proportional integral. Through that fuzzy PA controller only you are able to control the output DC link voltage up to 380 voltage. So here, and these are the membership functions. You can see here. You can see here, you people can see visible right here. So these are the membership functions we can say. Membership function 1, membership function 2, membership function 3. If you need more membership functions, so then go to edit, add membership functions, or remove all membership function also you can do. So then go to membership function, add membership function. So how many you need? So the membership function types also we have different membership function type. We have triangular membership function, trapezoidal membership function, Gauss-Seidel membership function, Gauss-Bella membership function, and sigma membership function. Different type of membership function we have. And here we are taking triangular membership function only. If you people select 7 membership functions, apply, okay. So then you will get here 7 membership functions. So then according to that you need to create the output rules, then you need to design. So if you take membership function 1, so whether it is a negative big, and you can say membership function 2 negative medium, and this one you can put negative 0 and negative small, positive 0, positive small, positive big, positive medium, positive, and here also output variables if you need also. If you go to here means, then you can check here. So here already we did some membership functions. We have power filter, right? If you observe this one fuzzy logic rules we created there, that we are, if you, this one is run one, so this is non-linear load. So the variable fuzzy variable and the error evaluating parameter fuzzy file and the undefined function or variable getting the error. If you click here, we are getting the error. So this fuzzy logic data we need to train fuzzy. Put the data import from file.fis file we need in error. So then again export to workspace. You can give one more time, export to workspace. So if you see here how the surface, we will see the surface viewer, right? So you can see here, go to error 0 and change 0.67 only, and these are the membership function e power minus 6. If you run your simulation and for controlling that Matlab and one universities, they are working on Matlab are there. So you can see taking some time. Now it's running. So before showing that results, I will tell here. So each and everyone here we are conducting IETE, and here with in association with IETE Mumbai chapter and Pantech internship program also we are offering. So in which area we are offering the internship programs means here internship on deep learning and AI using Matlab, machine learning using OpenCV and Python, electric e-vehicle design using Matlab. So in this e-vehicle also we are telling about what is our electrical engineer's role. So in that e-vehicle different advanced converter topologies. So in that converter topologies also bidirectional and converter topologies, isolated and non-isolated converter topologies, and we are trying to tell we will implement in this internship a new converter topologies which is LLC resonant converter topologies and dual active phase shifted converter topology. Here we are implementing. And the basic converter, if you are not able to understand about directly on isolated converter topology, means from starting itself we are teaching here. And in this e-vehicle, so with the T-type multi-level inverter, in this e-vehicle advanced multi-level inverter topology is also which we are using. So in that permanent magnet synchronous machines, so actually BMW cars in i3 model, Audi A6 or Tesla model cars, they are using squirrel cage type of induction motors. So for that one, T-type multi-level inverter with how T-type multi-level inverter using in EV applications. So T-type multi-level inverter with the asynchronous machines to controlling that speed control of asynchronous machines with the PI controller we are telling, and the fuzzy controller with PI controller of a BLDC motor also we are preparing. So most of the EV industry people, they are using BLDC motors only. So in this course also we are offering. So, and for short term courses, 5 days technical training program also we are conducting on Python, PCB design, embedded system training, Matlab programming and image processing, core Java, advanced Java programming, Android application development, IoT and cloud interface, VHDL program. In all these one we are offering 5-day technical programming also. Here I will show, before that I will show, before leaving I will show results also. You can see here the load current, compensating the load current, you can see here, and each and every one for technical management of Guru Nanak Technical Campus Management for arranging this session. Thank you all for patiently listening, all the participants who are patiently watching this session, and hope you people get some idea about the 1 hour time only. Then how it will work. I hope you people for attending this holiday time also. Thank you all for attending, and give your valuable feedback on the comment section. Subscribe our channel, those people who are newly attending this session, subscribe our channel. Just a minute. So once it's completed means we can able to see the results, grid current and what the load current and filtering current. So here we created all the subsystem data acquisition, we given the name, but in that subsystem we can see the, whenever we are using the power electronic devices, when we are injecting these power electronic devices, the only disadvantage of power electronic devices, harmonics, unwanted harmonics will be created. So the unwanted harmonics we need to eliminate. So then we need to reduce those harmonics. So we need to get the pure quality of the power means. So filters will place a role. Filters. So but the filters cost, initial cost of filter is very high. So the passive filter cost. So that's reason we are implementing the shunt active filters. When you make a shunt active filter product, a real time means the product cost will be also very low compared to the other filters. So here we will see. You can see here. Once it will be done means then we can able to see the waveform. You can send a mail 888841 or contact with our HR for training, any training 5P programs. You can contact to these numbers. So when we are training, when we are the same fuzzy logic controller what we created, same like that we will get the block, but the data which we are already Simulink we need to, so like that this power Just a minute, few minutes. I will show the result. Okay. Thank you all for attending this session.